ASTRO-CAptEvo is a framework for the adaptation and evolution of service-based business processes operating in dynamic execution environments. The CAptEvo framework offers a standard way for handling complex, dynamic, real-world business applications. In this demonstration, we will show the novel concepts and advantages of the CAptEvo framework when applied to a real and complex pervasive system. The scenario is based on business processes used in the terminal of Bremerhaven Seaport, where cars arriving by ship have to be delivered to retailers. Before the cars can be delivered, a series of activities needs to be completed, such as customization procedures. The management of car delivery is a highly complex process, as each car requires an individual treatment, and the process execution might be affected by changes in the execution context, such as car damages. This requires sophisticated modeling that allows for runtime adaptation and evolution of the application. In our demonstration, we will illustrate the CAptEvo framework in action and present the outcome of our algorithms to the end user. The environment enables interaction between the framework and the user by simulating execution, adaptation, and evolution of business processes in our case study. The demonstration is based on a set of entities, processes, and services. Each entity has its own process and relies on a set of services. Context properties express the state of the environment during the process execution. Here in this picture, we can see entities such as car, ship, truck, business processes, provided services, context properties, precondition and effects, goals. Each of these entities provides its own business process plus set of services. The process can contain set of abstract and precise concrete activities. The framework supports two types of artificial intelligence planning based dynamic adaptation, vertical and horizontal. The aim of vertical adaptation is to refine abstract activities of a process by automatically composing available services and obtaining a concrete process that can be executed. So as you can see in this picture that we have context properties, we have activity goals, we have the available services. In order to achieve the goal, the framework at runtime selects services, perform automatic composition to generate refinements. The other kind of adaptation supported by the framework is the horizontal adaptation, which results in a structural modification of the process instance by adding, changing, or removing process activities to retain the reachability of its original goals in case of a changing environment. It is a dynamic process adaptation in case precondition is violated. So for example, you're executing a refinement, you encounter a violation of precondition of this activity. For example, car status is not OK. You have the adaptation need that the car status should be OK, and you need to execute this activity again. The framework selects services to solve this adaptation need at runtime, considering the execution context, and then execute an adaptation process generated by selection of services and composition, and restart the process from the point it encountered problem. One can start the demonstration using the control demo button, which opens up a dialog box to specify number of small or big ships to start the simulation with. Within each ship, user can specify the number of normal, luxury, and heavy car. Press OK to start simulation. The visualization environment enables interaction between the framework and the user by simulating execution, adaptation, and evolution of business processes. During the execution phase, process models are instantiated and the corresponding process instances are executed. The framework is responsible for keeping the system configuration up to date and for consistently aligning the status of the context properties to the execution of the processes and to the context events. The system configuration is used by the framework to monitor context constraints associating a running process instances and to trigger adaptation in case of violation. By right-clicking on entity, user will be able to see the menu of the entity. Each entity has its own business processes and provided set of services that can be viewed using this menu. For example, the gate entity has provided services, lending guidance, prepare for departure large and prepare for departure small ship, prepare for large ship and prepare for a small ship. Similarly, the process instance is gate A for landing manager 2. Here, it specifies the way the different entities are correlated with each other using the process instances, which is 4 and 2 here. Similarly, one can view the different services and instances of different entities. Now we are going to show you the process instance of the ship process. The ship type is big. One can view the context properties in this right side bar. As you can see, the first activity of this process is the landing abstract activity, which is refined with two sub-concrete activity: land ship request, land ship gate 1 booked. Now we are going to see the process instance of the small ship. One can note that the same abstract activity landing is refined differently here. Now we are going to show you the system console associated with abstract activity. The idea here is to explain the techniques being used by the framework to handle such kind of adaptation problem. We have an abstract activity with a goal, that is to arrive to gate 1 or gate 2. We generate the adaptation problem. The problem is defined by the goals of abstract activity grounded to process instance of the entity and by the list of services and the list of objects. After that, the framework do the service selection. Here it selects relevant services, filter unrelevant ones that cannot be used for the precise adaptation problem. After this selection phase, the framework transforms the adaptation problem into planning domain that will be sent as an input to the framework planner. We have used a new planning as model checking technique, where model checker is new SMV, to transform the adaptation problem into a planning problem. Generated the planning domain, which is input to the model checker, which produce the planning results. The planning results represent the final refinement for this abstract activity after it is being transformed from planning language, which is finite state machine, to an framework language. Now we will visualize one of the process instance of the car. Here we can see that the car business process consists of set of abstract and concrete activity. Now we will make a precondition violation and demonstrate the process of horizontal adaptation. Now here we have a car damage. As you can see the red mark over car, which means that process stopped the execution. Now the framework needs to react to it. It will act accordingly and generate an adaptation problem, and result of this is the generation of adaptation process that can be viewed. So here we can see that the following concrete activity is in red and it's halted. By double clicking on this activity, we will see the adaptation process that the framework generates to handle this situation. This adaptation process will help to react to this situation and will put the overall process in the context with which normal execution is resumed. It means that the car is repaired and re-execute the request reply to move to storage and come back to normal process as visible on the screen. After executing the adaptation process, the execution will be resumed from the point it was halted. Now we will place the order for treatment and shipment using the new order button. The important thing here is that we want to demonstrate the occurrence of new entities in this demonstration. That is the truck, which is responsible for loading cars. The truck uses the service provided by the delivery gate to load different kind of cars. Using the process viewer button, one can see all the process instances in the environment. Double click on any process instance entry which are arranged by the instance type in this process list to view the actual process model and the execution instance. In order to start a new simulation run, use the control demo button and specify the input as demonstrated before. You can contact us on following email addresses in case you have any query or concern. For more detailed information about the project, please view the project details on the given web page link. Thank you.